We're live.
Yay!
We could do all sorts of damage right now, couldn't we?
We could.
I think Gigi's just said there was like 450 people on this webinar right now.
300.
Okay.
Almost.
I was joking about the 450. The 300 is really. This is why I woke up this morning at 2 o'clock. And we're ready. I mean,
Just breathe.
this is going to be great.
We got it. Okay.
Let's get started.
Let's do it.
All right, guys, welcome. This is the Setting the Standard for Desktop MSLA with Formlabs webinar. We're really, really excited to present some live action for you today. Setting the stage. I'm Simon Pinter. I am one of the application engineers here on the digital manufacturing team at Go, and I have a special guest in the Pleasant Ridge, Michigan office with me today.
I'm Joseph, normally out of the Atlanta office. Happy to be here visiting and learning about the Form 4 printers. Honestly, I didn't touch one until yesterday. So this is a good example of really how simple these printers are, and I am a fan.
Awesome.
So,
all right, very good. So here are the things we're going to talk about today, in addition to kind of show and tell. But number one, I want to make sure everybody is aware of what the printing process looks like. So how do we form a part?
Ooh,
Yeah, I had to do the ChatGPT to come up with a dad joke. We're also going to talk about a couple of new products that have been released by Formlabs that specifically cater to the Form 4 printer in the last couple of months. Number one is going to be the custom color resin. This is kind of a game changer, and you may think you know what custom color resin is, but some new and exciting updates. The Tough 1500 V2 material, we'll talk specifically about what the Tough 1500 material is intended for, but know that there is a new and improved version that was just released. Formlabs calls it the V2. And then finally, the second generation Form Cure. So we're going to be talking about the workflow for printing on the Form 4 system. One of the items in that workflow is going to be a UV post-curing process for the parts once they come out of the printer and they get washed. And we are now on the second generation of that machine. And I've got one behind me, and we're going to talk about that as well. All right. So with that, I get a little bit more comfortable.
leaves me all alone.
No. Joseph's going to be making faces at me in the background now, but totally fine. All right, so what is a Formlabs Form 4? And specifically, why is it awesome? And we'll make sure that my remote is actually working. It's not. Try that again.
Spacebar. There you go.
Hey. All right, now we're working. So, bird's eye view. The Formlabs Form 4 is a desktop printer family that uses the MSLA printing process. We'll talk a little bit more about what MSLA stands for, but just know that we're talking about a family of printers that use MSLA. The materials that are printed using this type of system are thermoset photopolymers. They start as a liquid plastic and they are cure hardened under UV light. And the thermoset, which, without getting too deep into the details, basically means it's a plastic that doesn't melt. It has some more exotic characteristics that can be taken advantage of in different applications. Specifically, the Formlabs Form series printers are industrial quality or industrial strength, but cost accessible. So think of the Formlabs system as something that can go on a desktop. It doesn't require hundreds of thousands of dollars of capital investment or infrastructure. You're going to see Joseph on camera here in a couple of minutes, standing in front of one in what is effectively a closet in our office. One of the key characteristics to printing on this type of machine is that the surface finish of the parts that you're going to get out of it are going to look nearly injection molded, without very much post-processing, if any. This particular system, the Formlabs Form 4, is really good at printing with many different types of materials, but also being able to switch between them very, very rapidly. There's a very broad material portfolio that I'm going to touch on. And the biggest one for me with this machine is that it is ridiculously fast. So how does the system work? here's a schematic of what the printing process looks like. And basically what you're watching is the build platform descending down into a shallow tank of resin. And underneath that tank of resin, which happens to have a clear membrane on the bottom, is a UV light source that's got an LCD panel over the top of it that is selectively allowing or blocking UV light from making it to that liquid plastic. Wherever the UV light hits, it hardens, and it's building up layer by layer as it's pulling the part out of that shallow vat of resin. I'll also point out in this schematic, there's that mixer blade that keeps going back and forth. We'll talk a little bit more about that when Joseph's in front of the machine. We talked about the printer, and we talked about how the material is a liquid photopolymer. I want to point out here that the form factor, that pun was not intended, but tremendous nonetheless, the form factor of the materials are in either 1 or 5-liter cartridges or pump-fed bottles. And I mentioned the resin tank. That's where the resin gets deposited throughout the build process. You take a look at the image on the right-hand side of the screen here, you can see the resin tank that is actively printing a part. You can see the existing part geometry down in the resin and the light source illuminating it from below. I am not going to go through every single one of these materials. However, I wanted to show you this very big list of materials to give you a sense of the breadth of capabilities that this machine has, all the way from low-cost, general-purpose prototyping materials that happen to be rigid, that may have similar characteristics to like ABS, all the way to elastomers. We've got a silicone 40 elastomeric material that's super squishy, and it is true silicone. We've got ceramic-based materials. We've got stiff materials. We've got polypropylene-like materials. There's even variants of this machine that are intended for biocompatibility with dental and medical applications. The software that we're going to talk about, this is the slicing software that the Formlabs, all of the Formlabs systems use for that matter. It's called Preform. You can even download it yourself right now. It is absolutely free. If you don't have a Formlabs printer yet, you can still pull up a printer template and poke around and see some of the controls that we're going to be showing off today. This is where we're going to lay out our parts. If the parts need support structures generated, those get generated automatically here, as well as being able to queue the build to your Form 4, or if you happen to have a fleet of Formlabs printers in your facility, you can choose which of those printers you're going to queue it to. There's other functionalities that are built in, things like hollowing parts. This isn't like FDM. We can't print with a sparse interior natively, but what we can do is we can take a solid part geometry. We can tell it to be hollow on the inside, and adding a couple of drain holes that allows us to make the same general part, but reducing the material consumption dramatically. And all of those functions are built right into this free software. The dashboard. I mentioned being in a facility that might have multiple Formlabs systems. I only have 2 Formlabs machines. I say only because I want way more of them in my office here in Pleasant Ridge. But we've got 6 total Formlabs machines at the company right now, and I can see any of the machines at a glance at our different facilities. I can see what jobs are queued to them, what jobs are running, who set them, what materials, how much material. And I can export all of this data as CSVs, so we can keep very extensive histories of utilization and get a better understanding of ROI on any given product or project at any time. So this is the really fun stuff that we're going to talk about today, and that's going to be the printing workflow. So I'm going to show you how to prepare a file, and then I'm going to hand things off to Joseph, and he's going to show you how to get it printed, how to clean the part, and how to cure the part. And we're only on the calendar right now for a total hour, and we are 10 minutes in, but I have a feeling we might be able to have a finished part by the end of this. What do you think, Joe?
We'll have a finished part.
Awesome.
Yeah.
All right. So without further ado, I'm going to go ahead and minimize our slide presentation. I'm going to try to.
Click on the right screen.
It's like
up on the main screen.
Up on the main screen.
Select the PowerPoint and minimize. There they go.
Nailed it. Guys, I'm going to learn how to use technology one of these days. See, the problem is PowerPoint's not made by Formlabs. If it was, it would be considerably more intuitive. All right, so don't mind me, guys. Anyway, we're looking at a live view of that preform software that I was talking about. And I've already got a two-part files rather that are in our build volume. But I got to make a couple of changes before we can send the part to the printer. Number one, I got to make sure I'm sending the parts to the correct printer. And I'm looking at an old school Form 3 template right now. That's not going to do. I need a Form 4. So I'm going to go ahead and change my machine to one of our company's Form 4s. Quick note, Formlabs doesn't believe in serial numbers, they believe in serial names. So Colossal Lark, that is not a name that was chosen by me. That is the name of my printer from the factory. Oh, and I'm going to go ahead and select the printer. And today we're going to be printing with the Fast Model resin, but you can see all of the other resins that are compatible with the system. I'm going to go ahead and click that Fast Model. And the geometry that we're printing with is suitable for a little bit heavier layer thickness. We're going to go with 200 microns.
Pretty simple geometry.
Pretty simple geometry. And I see a big red exclamation point here. We'll talk about why we're seeing that here in a second. I'm going to go ahead and apply. Give it a second. It's going to update. You'll notice we've got a bigger build volume than the old school Form 3. And what this is showing us is that the printer is ready to print, but it's currently got the incorrect material loaded in it. So when I get Joseph on camera, I set him up to have to change the material in our given time frame. He's going to love it. Work, work, work. Work, work, work. And he's going to go ahead and put in the Fast Model resin when we are ready. But in any case, here are my two parts. I've got a mode turned on right now where it's warning me, hey, Simon, you've got a couple of bits of the geometry that are not self-supporting. I'm going to warn you because there are no supports there and they may not print properly. This is actually not even the intended orientation for our build today. So I'm going to rotate the parts so that they are oriented most efficiently for print quality and for print speed. Just going to move them apart from each other. You'll notice that most of that red highlighting went away, but for these two little openings right here, and if you couldn't tell from the file name, this is an Arduino enclosure. I'm pointing out that it's showing right here. I am not going to build in supports. I want everyone to be aware that I am not putting supports in, even though it's telling me that I have to. Okay. What am I missing, Joseph? Is it ready to queue?
I think that's all you need to do.
Fantabulous. I'm going to go ahead and upload it to the queue. If we did have the machine prepared with the correct material and the correct resin tank installed, I actually would have had the ability to directly print. I wouldn't have had to even walk in front of the machine to press go. But I'm going to upload to the queue. And at this point, it is uploaded, and I am going to change your view so that you get to see Joseph. Even though it says Simon Pinter, I promise that is Joseph Miller.
All right. So changing material on this is insanely simple. I first learned this yesterday afternoon. All we have to do is first clean the print head, which we already did. It takes a few more minutes, so we did that ahead of time. But I'm going to unlock and disconnect this little mixer arm, unlatch the sides, hook on the tray lid, set that on our shelf, insert the tray with the correct material, connect the mixing arm, latch down the tray, or the vat. Then up at the top, you probably can't see it from there, but there's a little air relief valve on the top of the material canister. Close that, pull it out. So there's that little valve on the top. Drop in the correct material canister, open that air valve, confirm that I have latched everything in place, and then it's going to do a quick little pre-mix and warm up the vat for us.
So just a quick pause. Joseph, you just changed the material in a resin printer in under 2 minutes.
Yep.
And you have used this machine for a cumulative of
3 hours?
3 total hours?
At the most.
Yeah. I just wanted to make sure that everybody who's watching.
Yeah. I've worked with several other resin printers before, and to change the material on that involves taking it out the vat, draining it back into a bottle, usually through a filter. Always use a filter. And usually having to hold it by hand, and then try and scrape it out, wash the vat, and then put it in. You're talking like 20 minutes to change a vat on different resin printers. So the individual vat system, where you actually have a vat dedicated to a material, makes this material change faster than changing FDM. It really it's I'm in love.
We have an industry term for that, and that's, ain't nobody got time for that.
Yes, absolutely. So once this is finished doing its mix and warm up, we'll be able to select the print. Quick preview, one of the first parts that I ran in our little GoEngineer logo. This is in that colored resin that we introduced at the beginning, and we'll talk a little bit more about that here in a few minutes. I changed the vat, started the print, and had the print out and cleaned within an hour. The longest portion of that is letting it dry from the cleaning process, so you don't get weird cakiness when you do the final cure. It's really easy. So, all right. Simon, you want to start up or you got that part?
Yeah, why don't you go ahead and force it to start? So go to queue.
Go to the queue.
Now Joseph is scrolling through the queue of all of our builds and pressing play.
Okay, you got it.
All right, so
There it goes.
we are at 3:17 Eastern time, and the print just started.
Yep.
So we're all clear on that. Okay, thank you, Joseph. I am make this. Yeah, I think that's the right size. So I'm going to pull our slide deck back up. And while it's printing, we can talk about color resin.
Very good. Thank you. So, oh, excuse me. So the color resin is really neat. This isn't like a lot of other custom color mixes where you have to get the different dyes and try and drip in a specific number of drops and mix it by hand to create a color. Instead, you can choose among thousands of colors that have predictable formula for them. Next slide, please, Simon. So why would we want color resins like this? A lot of good practical reasons include, marketing displays, early prototypes where you want to show off the product colors or the brand colors, identify different parts of an assembly, training aids, signage. You can come up with lots of good uses for different colors. One thing to keep in mind, this is a part-by-part coloring process. So you do have to work with these as assemblies, but I just showed you the material change is really, really fast. You could easily print any one of those models on screen in just a few hours. You'd have all of them completed within a day. So it seems like a lot, but really it's very straightforward. Next, please. Clicky click. There we go. All right, so here's the order page for the resin. It's very straightforward, very simple. It's a lot like choosing a color in Photoshop. You can either enter in a very precise RGB or hex number for the color, or just use the sliders and pick something that looks good, right? Then you order that resin and it's shipped to you. It's custom made each time you order it. And you can order as little as just one container of it, which usually custom orders, they want you to buy at least a whole box, right? So the custom color is very simple, very straightforward to use, and you can choose thousands of precise colors and be very repeatable with it. Next, please. Once you receive your material, it gives you a code on the side of the bottle that you enter in to identify the print parameter that has been established for that color, and it will download those settings for you. You can tweak that if you need to as well and customize it even further, but it gives you a starting point right out of the box. That's really impressive. And I started this little green logo piece without any adjustments, and it came out perfectly. So the settings they provide you are reliable to start with.
Hey, Joseph, yeah, in case I wanted to make any changes to those settings, do I need some kind of a special license or anything like that?
No, because that one is built in with this color material option. The top right of that image is the create, import, or import custom print settings. So you can even share print settings with your coworkers for the custom colors, or if you're fine tuning a print material for the method you want it to print in, you can share those print settings. Works really, really well. And you use that same function for applying the custom colors.
One of my favorite things, Joseph, about the Formlabs resin printers is that they are designed to take them out of the box and just start printing with a couple of mouse clicks. You can make it as easy as you want or need it to be. But if you wanted to take control of the system, what I love about specifically Preform is the ability to go in and change any print parameters. That could be things like exposure settings or delay times, really, really granular, intricate details. I can change any of those things if I want to without needing any special access.
Which is really great because different environments, the materials print slightly differently. A resin would print differently down in my office in Atlanta, just a little bit differently. So I can go in and fine tune it, and that's nice. All right, key takeaways for the colored resin. You can choose any color that will fit in the RGB or hexadecimal identifying system, which is thousands. That has the same material properties as the V5 standard resins, the standard black, white, gray. You can order just one if you need to. It does only work on the 4 and 4L printers. And each order is a custom, well, my tongue stopped working here. Each order is custom made for that order. So keep track of the color codes that you want to use repeatedly, and you can just continually order the same colors. All right. Thank you, Simon.
Thank you. Okay. Maybe I should cut on camera. How's my hair? Okay. Great. I got a haircut this morning, and the guy put product in my hair, but like he didn't evenly put it in, so I'm like, I'm all over the, but as long as you think I'm okay, I'm happy. Not about hair, at least. All right, so I don't get a cool color to talk about, but I do get to talk about a material that's going to give us some more practical benefits from a mechanical standpoint. So the TUP 1500 material is going to be one of the closer to polypropylene, we'll call it polypropylene-like resins in the material portfolio. TUF 1500 V2 is the next generation of the material, and it is mitigating some of the initial, I don't want to call them shortcomings, but it certainly is taking the mechanical characteristics of the V1 and supercharging them to give us better elongation at break, better heat deflection temperature, things like that. So what's TUF 1500 V2 used for? Prototypes that need toughness and compliance. Again, this is like a polypropylene material. This is not something that you would use where you needed a stiff material. This is going to be where you need a part that has a little bit of flex or a little bit of give to it. It's intended for things that are going to be abused. Think an enclosure. I don't know, like a drill, a power drill.
Yeah.
You could take the enclosure printed in TUF 1500 V2 and throw it against a brick wall. I haven't tried it myself, so I'm going to just say it's definitely not going to break. The likelihood, though, is that it's going to bounce right off of that brick wall, may get a little bit of a scratch on it, but it's intended for really tough, heavy-duty applications, things that need impact resistance, tooling applications, production aids like jigs and fixtures. And it's not to say that this is soft like an elastomer. There's still an amount of stiffness that is required for a rigid application. But again, it's intended for compliance and for more ductility.
Would it work for like snap fits?
It is literally the best possible material in the portfolio for snap pins.
There we go.
The durable resin would be pretty good too, but it's a little bit too soft. I like the TUF 1500 because it gives us a little bit more. A couple of, I wanted to show like a whole mechanical technical data sheet, and Joseph was like, that's way too much information to show them. So a couple of things that I do want to highlight though. Number one is a significantly improved elongation at break and a really decent heat deflection temperature for a material that has the ductility that this material has. Traditionally, with liquid photopolymer resins in any manufacturer's printing process, the more elongation at break that you have, the lower the temperature resistance is going to be. Unfortunately, it's kind of a hand-in-hand kind of thing, but the TUF 1500 V2 gets us to that next level in heat tolerance. I have here on this slide, it's great for drilling and tapping without chipping or fracture. Traditionally, if you were to take a self-tapping screw and try to drive it into a we'll call it a general purpose prototyping material coming off of any resin printer, you're going to see all sorts of chips coming off of the surface.
It doesn't just break.
It doesn't have to break in half. There's certainly a durability limitation on some of those legacy systems. But this material works. I've seen it with my own eyes. It works really well. You can take self-tapping screws and literally drive them into parts without them chipping, without them splitting. So a couple of things to take away. It comes in the same 1 liter bottles like what Joseph was showing off on the printer behind us. It also comes in the 5 liter container variants. And when you want to be printing with the larger bulk versions of these materials, you would get an accessory resin pump that physically pumps the resin out of that bottle into the printer. It has material profiles that are optimized for 100 and for 50 microns, but since you have access to make all sorts of different changes to your heart's content, I really love that Formlabs does most of the hard work for me, so I'm going to stick with their 100 and their 50 micron profiles. It is a material that is only going to be compatible with the Form 4 and the Form 4L, and it's got a really good shelf life, even once it's been dispensed from the resin cartridge into that resin tank. It's relatively stable for a long period of time. This is a single part material. It's not 2 parts. It's not like it's going to go bad in 8 hours once it gets deposited into the resin tank. Post-processing is super simple. When parts come out of printers like these, they're still going to be wet with that photopolymer. It's technically a hazardous material. We certainly don't want to get it on our skin. We need to get it off our part. So the post-process, Joseph's going to show it all off behind us once the print is done, is just a handful of quick steps. Number 1 is going to be the washing of that residual resin. And depending on the age of the solvent that you're using, we're using relatively old isopropyl alcohol. About 10 minutes in that solvent will have most of that residual resin away. Our second generation form cure, I'm going to talk about that in a second, One of the huge benefits of the second generation form here is how much faster it is than Gen 1. So 12 minutes is the total cure time for the TUF 1500 V2. And that's actually one of the longer cure times of all of the materials on this new cure station. There are still folks that have the first generation Form Cure, and there are folks that have the Form Cure L, the larger format system. Those do have a little bit lower intensity light on the inside. They still do a really good job, just takes a little bit longer, about 60 minutes in that final UV post-cure, which takes our part from a green state where it's still kind of soft and takes it to those technical data sheet ASTM specifications. Hey, I mentioned the second generation Form Cure. What a great opportunity. I am not going to read this all to you, but the biggest takeaways that I want you to take from this webinar, as far as the Form Cure second generation is concerned, it will fit a full-size Form 4 build. That is something that is not true of the first generation Form Cure. A part that takes up the full build volume would not necessarily fit in Gen 1. Gen 2 will take a full-size Form 4 part. It is ridiculously fast. The model resin that we are using right now and that Joseph is going to be showing off, the UV post-curing time in the new curing chamber is 1 minute.
It's pretty great.
1 minute.
It's great.
What I really like also is this user interface on the front of it, where all of the Formlabs resins, the library is on that UI. And you just select the resin that you want to cure. It's going to pull up that specific resin's intended cure time and its required chamber heat, and it will apply both of those when you hit the start button. Set it, forget it, walk away. It used to be, though, that you could walk away and like go get lunch.
Right.
It was 60 seconds. Yeah.
It's almost not worth leaving the room.
You can't get that much done. So this is a really awesome slide to give you a sense of how much faster the new cure station is from the old. So TUF 2000 resin, which is a relative of the TUF 1500, on the Gen 1, it is 60 minutes. Gen 2, 7. I'll just let everybody absorb that. Now, high temp resin required 2 hours in the old cure station, 15 minutes in the new one.
And that's impressive for high temp materials. They need to absorb the heat and sit with it for a while to achieve their full properties.
Yep.
So,
very good. So here are just a couple of technical doodads that are showing you the differences between the units kind of under the hood. But biggest takeaways, again, it's a bigger system. It's got a clear glass turntable so that the light source underneath the parts and then above the parts, on the side of the parts, you're getting even light all the way around as that turntable is spinning. It's a much higher irradiance light source. And the chamber heaters are much, much more powerful. So the chamber heats way faster. And if you're one of those lucky folks that's out in Europe using the 230 volt system, it gets hotter even faster than the 110 units for North America. But I promise the North American ones are still really good. All right, so there's one more thing that I want to share before I hand things back to Joseph. And that is, we love the Form 4. We're talking about it. We're next to it. I'm a little guy, but I can give you a pretty decent sense of scale with me standing next to it. Build platform is 200 by 125 by 210 millimeters. That's pretty big. It's definitely bigger than the old Form 3 and Form 2.
Yeah.
And that'll fit the needs of many, many, many customers. There are some folks, however, for whom they're going to need more space. And for that, there's the Form 4L. And I'm going to interrupt myself and just point out that the print just finished, but I'm not going to let you touch it yet. Let me finish this slide, then you can have it. It chirped at us. So the Form 4L, same machine, same, functionally the same materials, bigger resin tanks, and obviously much bigger parts at 353 by 196 by 350 millimeters. So if the Form 4 is not big enough for your application, Form 4L might just be.
It's pretty big. It's huge.
All right. So let me get you back on screen here.
Thank you, thank you. So pretty impressive how quickly that finished. And if you do look at getting a form for your office, definitely get the head with the ejection triplet. because that's just so convenient. The little lid over here, it's pretty thin. It's going to need a little help.
Now, typically,
Pop that down.
we would be doing that with the build head out of the system, but for the sake of the demo and Joseph only having 2 hands,
Yeah.
he just did it also while the build platform was still living in there.
No. All right, so still coated in resin, so we got to pop it into our cleaning system. And this is almost as cool as the printer itself. I placed the parts into the tray. It goes down by itself. There's a little flapper to keep the isopropyl from evaporating when it's not in use. And off it goes. Very, very cool system. It just works.
So now, Joseph, while that's cleaning, or it's prescribed 10 minutes, we're not going to make everybody wait while that's happening. So maybe you can show us the form cure with the already clean parts.
Yep. So we did run these a little earlier, printed, washed, same settings. This hand has more resin on it, so I'm only using one at the moment. But ready to go.
Actually, Joseph, before you put it in there, can you just show everybody that area on the part that I pointed out that didn't have any supports on it?
Oh, right. Yeah, that little bridge. We can get that to focus, right? Came out perfectly. There isn't any warping, bowing, broken space. That's impressive.
0 supports used on this entire print.
It came out like, wow. All right. So into the Cure 2. Make sure it's set to the correct model material for what you're using. It has its own presets. I don't know if you can see the countdown here, but it started at 60. It's super fun and super fast, super easy. I am a big fan. All right, so
Joseph, I'm going to put you on the spot a little bit here.
Quiz time.
And there's no right answer to this, but let's hear your take. I mean, you've been in additive for many years, but your exposure to this system is literally hours old.
Yes.
How would you describe the entire process that you have gone through here relative to every other printing technology that you've ever experienced?
I'd say it's right up there with FDM in reliability. Like, I just have the confidence that when I put in the part and hit print, I can walk away, I'll come back, and I expect it to have succeeded, right? The learning curve on it, on the systems, is very easy. I picked it up after one quick little sort of training. And then Simon's like, hey, go get the material ready for our next print. And I came in and I did it. And it's very, very simple. It doesn't take a lot of time to learn. The software, there are enough nuances and little variations that one will take a little time to master. But the presets are such that you can trust the presets to the prescribed materials and just run with it. So, yeah.
So
5 out of 5 stars.
Oh, yeah. I mean, that's definitely my thoughts exactly. What I want to do here, Joseph, is I'm going to go back in time. Whoa. I'm really putting you on the spot. We're going to look at this.
All right.
So looking at the material portfolio.
Okay.
As of right now, you have printed with fast model resin and you have printed with the custom color resin.
Yes.
What are you next excited to print with that you see on this list?
Oh, I would like to actually run the rigid, is it the rigid 10,000?
Rigid 10K? Yeah, we actually just got a bottle of it.
Ooh, fun. I've helped customers with applications that needed that material, but since I don't have a form in my office, I had to send it out to other teams that do have it. And the customers were very impressed with it. It was a water impeller So it needed to take a beating and needed to be able to withstand exposure to liquid. And last I heard, the customer was impressed with the quality of the model. So I want to try that one.
Yeah, and what's really cool about the rigid 10K, and I believe the 10K is referring to the flexural modulus of the material. This is, we talked about some of these exotic material characteristics. This is a liquid photopolymer, but suspended in it are glass beads, very small.
Was that what's in it?
Yes.
Oh.
Yes. It looks very similar to some other manufacturers' ceramic materials, but it is explicitly glass.
I got you.
There's also a sibling to the Rigid 10K that's called Rigid 4000, also used in glass media, but it is a lesser content, so you're not getting the same level of stiffness. But Rigid 10K is perfect for any application where you might need high stiffness, high temperature resistance, high chemical resistance, low water absorption, things like that.
Yeah, I think so.
Awful if you need something soft and snap fitting. The worst.
Don't use it for your snap fit clamshell case. Check. Okay.
All right. So I think our part has been done for like minutes already.
It's totally done. All right. So fully cured. Don't need the gloves anymore. Right. And this part, we tested a couple of these, so I know this one's just a little snug, but it still slides right together just like we'd expect. So this fast resin for quick test prototypes, make sure your design is going in the right direction. Can't beat it. Super fast, very accurate, and if it's just a first run prototype, doesn't have to be beautiful, but it's not bad.